Alright you guys, so for the ninth problem we have to solve a rope simulation. For the first question the problem will be very simple. We'll have only two nodes connected by a line and we have to simulate how this setup moves. So the head will be able to move around in four directions, up, down, left and right, and the idea is that the tail needs to always be touching the head, so each move it will have to follow the head around. If the head is ever two steps directly up, down, left or right from the tail must also move one step in that direction so it remains close enough. If the head and the tail will be diagonally separated but still touching and the head will move further away from the tail will have to move diagonally to catch up to the head. So they give us an example of how the head and the tail will move around, and we have to count all the spots where the tail will be after the simulation is done. For the second part we increase the complexity of the simulation, and instead of simulating only two nodes we'll have to simulate 10 nodes. The rules will be similar, so the second node will follow the first node, the third node will follow the second node and so on. And what we have to compute is the number of spots that the last node will go through. So for the solution I created an enum called move that will have four constructors, one for moving up, one for moving left, one for right and one for down. Then I implemented the from string trait for move, and parsing the input was really simple because each line was a character that indicated the direction, then a space, and then a number that indicates the number of steps that you need to make in that direction. So I read the entire input from the file and then I converted each line into a move. Then I created a struct called point that can hold an X and the Y position. Then I created an apply move method that will change the point, and basically what it does is to move the point in the direction and the number of steps indicated by the move enum given as parameter. Then I have a function called isTouching that checks if two nodes are next to each other or overlapping. The step follow function computes the vector of the direction that the tail needs to move towards the target. So this is computed as X error and Y error. Then we compute the sign of this vector and then we move the tail one step towards the target, and we also keep track of all the points that were generated during the following. So for the first part we create 2 points, one for the head and one for the tail, and we'll have a hash set that counts the unique points where the tail will reach. Then for each move that we have in the input we apply the move on the head, and while the tail is not touching the head we have to step towards the head, and we also modify the map to contain the generated point along the way. And finally we just get the length of the hash set. For the second part the idea is very similar, but instead of creating only 2 nodes we create a vec of 10 nodes, and in the map I guess we can keep hash set only for the last node, but I already had the function that needs a map as input, so I created a hash set for each point in the vec. Then for each move I applied the move onto the head, and then maybe this was a common mistake because I also did it. I tried to simulate each node until it got close to the head and then go to the next node, but what you actually have to do is to simulate one step at a time in each node. So you go through all the nodes, and if they are not touching the parent head they have to move one step, and after each node moves one step you go again from the beginning until all nodes are touching the head, so they don't need to move anymore. Then for the answer we just get the last map and return its length. So yeah, basically this was the 9th day. It was really interesting. I saw a lot of cool simulations on the Advent of Code Reddit and also on YouTube videos. So yeah, I'll leave all the links in the description, and yeah, see you guys next time.